Hey everyone, good morning. I am Rianshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is construct binary tree from pre-order and post-order traversal. Okay, so let's see what is this question and how we can solve it. So in this question, you are given two integer arrays, pre-order and post-order, where pre-order is the pre-order traversal of a binary tree of distinct values and post-order is the post-order traversal of the same tree. Reconstruct and return the binary tree. So if you don't know what are pre-order and post-order traversals, so let me tell you. So let's suppose if we have tree 1, 2, 3. So pre-order means pre. So root should come first. So pre-order is root, left and right, and post-order is left, right and root. In post-order, root comes after left and right, and in pre-order, root comes first. So what will be the pre-order traversal of this tree? It will be root 1, left and right, and post will be left, right and root. Okay, so pre-order traversals are nothing, just left, root, left and right, and post is left, right and root. Okay, and if there exist multiple answers, you can return any one of them. Okay, so if we are given with the pre and post order traversal of a tree, so can there be case like a two different tree can have same pre order and post order traversal? Okay, let's see if it is possible. So let's say we have some tree, let's suppose A, B, and some tree, let's suppose A and B. Okay, now let's write their pre-order and post-order traversals. Okay, so pre-order is root comes first and then left and there is no right child, and in post-order left there is no right and then root. Okay, now let's write the pre-order and post-order traversal of this tree, which is root, no left child and then right, and left there is no left child, then right and then root. Oh, they are pre-order traversal and post-order traversal. Both are same, but the trees are different, right? So that's why you have been given in the question that if there exist multiple answers, so you can return any one of them. Okay, so we will consider this case like first we will create a node, and if that node doesn't have any left child, then we will attach a left child to it, and if already have left child, then we will attach a right child to it. Okay, so this is the case in which two different trees can have same pre-order and post-order traversal. This is one of the many examples, there can exist more as well. Okay, now let's see the test case. So in this test case, you have been given the pre-order and post-order traversal, and you need to reconstruct this binary tree. Okay, so first let's try creating the pre-order and post-order traversal of this tree. So the pre-order traversal will be root, this is 1, and then left, which is 2, and then left, because we need to go to the left and left and left to that root, right? So this will be 4, 1, 2, 4, and then right. So this will be 5, and then we need to go to the right subtree, which is 3, and then to the left, and which is 6, and then to the right of that subtree. So this is 1, 2, 4, 5, 3, 6 and 7. Okay, now we need to create the post order traversal. So in post order, what we need to do is left, root and right. So first go to the leftmost node, which is 4, and then right, which is 5, and then its root. Okay, now we have completed the traversal of this left subtree. Now we need to complete the traversal of this right subtree. So we will start from left, which is 6, and then 7, and then 3, and then root, which is 1. So it will become 1, 5, 2, 6, 7, 3 and 1. So what we have done is, let's say 1 was our root node. So first we have completed the traversal of the left subtree, and then we completed the traversal of the right subtree, and then the root. And for the subtrees as well, first we will go to the left subtree, and then right subtree, and then root. And for this as well, first left subtree, and then right subtree, and then its root. Okay, so in this way we can create the post order traversal, pre and post order traversal of our tree. Okay, but now we have been given with this pre and post order traversal, and we need to create our tree, we need to construct our tree. Okay, so how we can construct our tree with these traversals? Okay, so let's say in the pre-order and post-order traversal, this is pre-start, this is pre-end, and this is post-start, and this is post-end. So I will represent it with these short forms: PS, PE, capital PS, capital PE. Okay, so as in the pre-order traversal is root, and then left, and then right. So obviously first node is going to be the root node, right? So 1 is going to be root node, which we know. Okay, so 1 is going to be root node, this is very sure. Now after the node our left subtree will start. Okay, so it means PS plus 1 is the starting point of our left subtree. Okay, and till the pre-end is the ending point of our right subtree. Okay, but we don't know at which point we need to break our left or right subtree. Okay, so how we will get to know that at which point we need to break it? Okay, so let's see if we search for that PS plus 1 element in our post order traversal. Okay, so you can see that the size of the post start and the index at which we found that PS plus element, it contains 3 elements. It means this is the point where our left subtree ends. It means our left subtree contains 3 elements. These are 2, 4 and 5. And how we will do find the index of that element in the post order traversal? So either we can create a post index map, or we can also just do iteration in the post order vector. Any of the ways is fine. Either we can do a lookup or create a map, but we will create the map so that we don't need to iterate it again and again. Okay, so what we get to know from here is that the point at which we find the PS plus 1 element in the post order traversal will help us finding the breaking point or completion point of our left subtree. So the number of elements, which let's say this is right, this is left, so r minus l plus 1 will give us the number of elements our left subtree contains. So here it is 3, so this is our breaking point, 2, 4 and 5. Okay, and obviously 2 is going to be starting node, as pre-order traversal is root, left and right. And after this, PS plus size of left subtree will give us the post start point for our right subtree. So this will be our new PS for our right subtree, and this will be our starting node, or this will be our root node for our right subtree. Okay, so what we have derived from here is that the size of left subtree is going to be post index of left subtree root minus this PS plus 1. So this will give us the size of our left subtree. But what is this left subtree root and how we will get it? So our left subtree root is nothing, pre-order of PS plus 1. As here we have seen that pre-order of PS plus 1 is always going to be our root of left subtree or root of right subtree, whatever we can say. In this case, like, it will be the root of right subtree. Okay, so let's try to write some pseudocode from the observations we have derived till now. So what we need to do is we need to construct this binary tree with pre-order of start, pre-order of end and post-order of start. So root is going to be the pre-order of start. We have seen it. Left subtree root is going to be pre-order of start plus 1, and the size of left subtree will be post index of left subtree root minus post start plus 1. Okay, now how we will create our left subtree and right subtree? So for the left subtree, our post start is going to be PS plus 1, right? And our pre-start is going to be PS plus 1, and our pre-end is going to be this index, And how we will get this index? PS plus size of left subtree. As you can see, 0 plus 3, which is 3. So this is going to be the pre-end for our left subtree. So which is PS plus size of left subtree size, that's it. And post start is going to be post start only for the left subtree. And for the right subtree, what these parameters will become? Now we need to see pre-start. So pre-start will be pre-start plus size of left subtree plus 1. Like the tree at which, the point at which our left subtree is ending, plus 1 will be the point where our right subtree is starting, and pre-end will remain as pre-end, and post start will be post start of size of left subtree, as you can see here, left subtree size. Okay, so we can simply incorporate these parameters in our pseudocode. Pre-start of left subtree size, comma post start, and in the right subtree our pre-start will become pre-start plus left subtree size plus 1, and pre-end will remain as pre-end, and post start will become post start plus left subtree size. Okay, so let's try run this approach so that you will get a better idea. Okay, so these are the pre and post order traversal of our tree. Okay, now this is pre-start, this is pre-end, this is post-start, and this is post-end. Okay, now we know that this pre-start is going to be the root node. Yes, and pre-start plus 1 takes some value, and pre-end is going to be the left and right subtrees. Okay, now pre-start plus 1 is 1, and post pre-end is 6. We know the index is 0 1 2 3 0 1 2 3 4 5 6. Cool, we know these values. And how we will get to know the end of this left subtree, which was pre-start plus size of left subtree. Okay, so the size of left subtree, here we can see that this index minus this index plus 1, so which is 3, and pre-start is 0 plus 3, which is 3. So the ending point of our left subtree will become 3, and the starting point will become 4. So now we have got the indexes for our left and right subtree. Now let's make a call again at this left subtree. So here you can see for this left subtree, now PS will be 2, PE will be 5, and post start will be 4. Okay, so obviously this PS is going to be the root node, and now we need to find the indexes for the left and right subtrees. So for the left subtree, the index will be 0 1 2 for this 4. Okay, and we will do a lookup in our post order map, and 4 occurs at this index, and there are no values before this, so it will end here only. And for the right subtree, it will be 3 comma 3, and then there comes a base condition that if these values are equal, then we will simply return, and these nodes will get created. So this value will become 4, and this value will become 5. Okay, so now what we have constructed, 1 2 4 and 5, right? Okay, now let's try constructing our right subtree as well. So for the right subtree, the starting point was 3, ending point was 7, and the post start was 6. Okay, so obviously 3 is going to be the root node, as pre-start is the root node, and then this will become pre-start plus 1, and then we do a lookup in our map that what's the index of this 6. So it is 0 1 2 3, which is 3, and minus post start, which is also 3, plus 1, so it is 1. So it means only one element will come in the left subtree with index 0 1 2 3 4 5, this one, from 5 to 5. Similarly for the right subtree, only one element will come from 6 to 6, and this will come under base condition. If the pre-start and pre-end, that is pre-start equals to pre-end, as you can see here in these base conditions, then it will simply return and create the nodes. So what we have created here is 3, 6 and 7. Let's match it with our given answer, given tree 1 2 3 4 5 6 7. So in this way we can create our binary tree from the pre-order and post-order traversal. Okay, now let's see its code so that we get a better idea. So in the function construct from pre-post, we have created a post index map which will not do nothing, just store the indexes of all the values. So here we are storing the indexes, and then this is pre-start, this is pre-end, this is post-start, and this is pre-order traversal, and this is post-index map. We don't necessarily need to create it. We can either do a lookup here in the post-order traversal, but this, I think this was easier for me, so I have created this map. Okay, so now these are the base conditions. If pre-start is equals to pre-end, then we simply create that node and return. Otherwise, if pre-end is less than pre-start, obviously this is not a valid condition, so we will simply return null pointer, and we will create a left subtree root with pre-order of pre-start plus 1, and left subtree size will be post index minus left subtree root minus post start plus 1, as you can see, as I have explained in the approach. Now we will create a root node with pre-order of pre-start value, and let's construct the left and right subtrees with the values like this will be the pre-start, this will be the pre-end, and this will be the post-start, and similarly this is pre-start, pre-end and post-start, as I have explained in the dry run or in the complete approach as well. So now let's talk about its time and space complexities as well. So this will take n, this will also take big O of n, and this complete iteration, we are just doing iteration in our complete pre-order traversal for constructing the tree. So its overall time complexity will be big O of n, and its space complexity will be big O of n for creating the map, and big O of n for the recursive stack space. So it will be around big O of n only. You can also avoid this complexity by not creating the map, but this is not a very big deal even if we are creating this map. So yeah, the overall time and space complexities are big O of n. And yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.